Hello, mathematicians. In today's video, we'll be identifying linear and nonlinear functions from tables. By the end of today's video, you should be able to say, I can determine if a function is linear or nonlinear from a table. So you can determine whether a function represented in a table is linear or nonlinear based on the rates of change, or the slopes, right? So if the rate of change is constant, the relationship's going to be linear, right? If it's not constant, it's not going to be linear. So for example, on the left here, you see a decrease of 2. So -2 is the change on y, and the change for x is +5. So you would remember, rates of change is the change in y, which is also the slope, right? Change in y over the change in x. So in this situation, you get change in y is -2, your change in x is 5. And so the function is going to be linear because all of these pairs of coordinates have the same rate of change. Whereas if you go to this nonlinear one, the rates of change goes 3, 5, then 7. So they're not the same. Therefore, the function is non-linear. Example 3. Identify linear and nonlinear functions from tables. The table shows the minimum number of daily calories a tiger cub should eat based on its age in weeks. Determine whether the function is linear or nonlinear, and explain. So we're going to do x for age and y for minimum calorie intake. And I'm thinking of, I want the change in y divided by the change in x, typically here. So between 825 to 1,000, let's do our little loopies. So from 825 to 1,000, let's see here, 1,000 minus 825, we get 175. So plus 175 here. Then from 1,000 to 1,185, it's plus 185. And then 1,320 minus 1,185. Then it turns into plus 135. Weird. And then plus 100. At 3 weeks, we really peak on the calorie intake. My goodness. And then the weeks just keep going up by 1. So that's pretty constant over here. The problem is that from week 1 to week 2, the rate of change is 175, right? Because it's 175 divided by 1. But then from 2 to 3, we get 185 over 1. So the rates of change are not the same. So the function is nonlinear. And now it's time to check your understanding. Determine whether the table represents a linear or nonlinear function, and explain your reasoning. And yet again, we want to figure out if the rate of change is constant. And we can do that by looking at the change in y and the change in x. So let's see, we go from 9 to 16 with plus 7. 16 to 25, what is that, plus 9? And then 25 to 36 is 11. And over here we get plus 1, plus 1, plus 1. Well, the rate of change from 3 to 4 is 7. And the rate of change from 4 to 5 is 9. And the rate of change from 5 to 6 is 11. These are not the same, right? The rate of change has to be the same for it to be linear. So therefore, this is a non-linear function. In today's video, we determined if a function is linear or nonlinear from a table.